Right, so now we're going to get into solving these logarithmic equations using this one-to-one property. This one-to-one property was found in your notes that we did on our class, last week. So with section 3.2, believe we were looking at those properties. So with these, we are looking at this one-to-one property that tells you that you can go ahead and simplify things down. This one-to-one property for logarithms states that if you have a base of 10 of log to the x, that is the same thing as saying x. And if you have e to the natural log of x, that's the same thing as saying x. Something about that log and that e together cancels things out. Well, that something is the rewrite. The rewrite of a basic logarithm going from an exponential that we looked at. Log base 10 of x equals log x. If there's no base there, it is a 10. So that's the proof behind it. It's the same thing with natural log. If I have natural log of base e to the x, and that equals my exponent ln x, well, that is a secret base e as well. Okay, so we are going to take the knowledge that these properties hold true in order to solve some of our equations. Now, if this one-to-one property doesn't make 100% sense in your brain, you can also use the rewrite to solve it. So in this first one, I will show you both ways, and then you guys get to pick the one that works best for you. Personally, for me, the rewrite works way better for my brain than this one-to-one, but it is important to know both ways. All right, so we are going to go ahead and look at, you've got two methods. So the first one is using exponentiation. You can call it the exponent thing. I don't mind. Okay, so our problem is 2 natural log ln x equals 18. We're going to need to go ahead and solve that. So my first step is I've got 2 ln x equals 18. I'm going to divide by 2. That's going to be my first step. I really only want this natural log of x on one side, and then I've got 9 on the other. The exponentiation says that this natural log has this little base of e, and we're going to now take it from the natural log form and write it in the exponential. So that means I've got e to the 9 equals x. Our base to the exponent equals that value. And then from here, you can plug it in to your calculator. So that means you've got 8x is about 8,103.08. Okay, that's using that exponent rule. Now, the other way to do it, honestly, it's very similar to the first. They're both using exponents, but now this one, we've got this, we're going to take it up from the beginning where we've got 2 natural log of x equals 18, divide by 2, and then you get the natural log of x equals 9. Now, what we're going to do is, you know how when we were solving the last one, if they had the same base, you could then go ahead and cancel out the bases and just work with the exponents. What we're going to do is we are actually going to take this equal sign and we're going to make it our exponent. So we're actually going to take an e down at the bottom. And the reason why we're using a base e is because if you look at that property right there, that one-to-one property says that if it's e raised to the ln of x, it's going to actually equal x. So that e and the ln cancel out basically, and we've got x equals e to the 9th, which is 8,103.08 approximately. Hopefully you can see what one is necessarily the easier one, right? Rewriting it into exponential form, but for some people it may be the other way. So just that you guys are aware of both, those are both of them, and you guys will be able to pick what one you would prefer. Now I'm going to walk you through another example. This one is a little bit more difficult, so I won't release you to try one on your own yet. I want to show you guys how, kind of the steps of this. So we've got 7 minus 3 log 10x equals 13. Now this looks kind of gross from the beginning, but if we take it one step at a time, it's not too bad. All right, your first step, subtract 7 on both sides. So you have negative 3 log 10x equals 6. We're going to divide by that negative 3 that's at the front. Then we get log 10x equals negative 2. I'm going to go ahead and rewrite. What are we going to rewrite it as? Well, we've got that invisible little 10 base because nothing was there. So that's 10, our base, to the negative 2 power equals 10x. Now, we've got 10 to the negative 2, and we've got 10x. We need to divide by 10x, divide by 10. If we have 10 to the negative second over 10 to the first, we could kind of use our exponent rules. And if we have negative 2 over a 1, and they're both in the exponents, we use subtraction. So 10 raised to the negative 2 minus 1 is 10 to the negative 3, which is 1 over 1,000, which is our x value. Hopefully now you can see that it's a little bit more complicated. The next one is going to be on you, so I want to see you try it.